Welcome back, class. This is week 8's video, so we're moving along in the first 9 weeks for this school year. We're already almost a quarter done of the school year, which is awesome. Think that time is flying by. But for our assignments for this week, I was telling our class last week how for this week, week 8, it's kind of going to be an easy week because I do want you guys to get caught up on all of your schoolwork, not just for my class, but for your others as well, because I've been hearing that things are starting to be due and our grades may or may not be suffering a little bit. I want you to use this time to do an easy assignment because this week's lesson isn't going to be that difficult, but use this time to get caught up because I'd rather you get caught up now and not start having to cram next week, which is the last week of this 9 weeks. Okay, I'd rather everything be good to go, all loose ends tied up for next week so that we're breezing through to the new 9 weeks. Okay, so all I want you to do, the only graded assignment for this week is the 2-1 practice problems. Now that's both my in-person and virtual students. You also see a folder inside of, for my virtual students, you'll see a folder that says enrichment, red tide analysis. And what that is, there's a separate video I'm going to make. It's a good way to see how math is involved in a current event. So things that are going on around us and how is math involved in it. So if you like science, give it a look. This assignment, what it does is that it ties together everything we've learned so far and what we're going to be learning this week inside this video. And it pieces together how that is involved in our real world events. Okay, and just to give you a little sneak peek, it's about hurricanes. So really, again, the only graded assignment is this 2-1 practice problems. The enrichment assignment, you can submit. I will be looking over your answers, but it is not going to be a grade in the grade book. The biggest thing, like I said, is I want you to look at all of your grades for all of your classes. So go to the grades tab on Schoology and see if there's anything missing. If it's a 0, see if it's a 0 because it's missing, or see if it's a 0 because you just didn't do too well on it, right? Check that out because most teachers, I know for me and I know for a few other teachers, you can still turn in, even though it's late, you can still turn in an assignment, okay? Just make sure that these assignments are getting turned in now before the end of 9 weeks because your teachers, we still need to grade things, right? So keep an eye on what's due, see if there's anything that's missing, and just use this time to really catch up, okay? So let's dive into the lesson and see what we got in store today. Per usual, let's start with a warm-up. This warm-up deals with what we were working with last week and the week before, which was dividing fractions. Just to give you a little quick summary in case you forgot, when you divide fractions, what you want to do is you want to keep the first fraction the same, change division to multiplication, and find the reciprocal of the last fraction. Okay, so I'll get you set up for the first one, and then I'll have you pause the video, finish the problem, and then try the problem over here. All right, so let's look at the first one. It says 8 divided by 1 1/4. If you remember, anytime you have a whole number, you can write that with a 1 underneath because 8 divided by 1 is just 8. It's not changing the answer. So we keep this the same. I'm just going to write division for now because we'll worry about the keep, change, flip after we change this mixed number. Now this mixed number needs to be changed to its improper form, and we do that by doing 4 times 1 plus 1. 4 times 1 is 4, plus 1 is 5, so this is really 5/4 as an improper fraction. Now that this is nice and lined up, now you can keep, change, flip. So keep this the same, change to multiplication, and then give me the reciprocal of 5/4. All right, so pause the video, try finishing this problem up, and then try this problem over here, and we'll look at our answers together. Okay, so hit pause. Okay, hopefully you gave yourself enough time. Let's go over the answer. So again, we keep this the same, we change this to multiplication, and we flip, and we find the reciprocal of 5/4. So this is 8/1 times the reciprocal of 5/4 is 4/5. Then you want to multiply straight across. 8 times 4 gives you 32. 1 times 5 is just 5. Now the last step on this is that you want to change this improper fraction back to its mixed number form. The way you do that is you just divide the bottom number into the top number. So 5 into 32. Well, 5 can't go into 3. 5's too big. 5 can go into 32, not evenly, but the closest you can get would be 6, because 5 times 6 is 30. And when you subtract those, you get 2. Everything you need to make your mixed number is right here. I showed a group today in class how it kind of, to set it up, it kind of makes a clock. You start at the top, right, at 12 on a clock. You use that 6. So 5 goes into 32 6 times. Then you move down to this 2. You write 2. And then you move up to this 5. So it's 6 2/5. And that's your answer. 6 2/5. That's the mixed number form of this improper fraction. So let's try this one over here. Same thing. We want 12 over 1. We need to change this to its improper form. So 2 times 1 is 2, plus 1 is 3. So this is really 3 halves. We're going to keep, we're going to change, and we're going to flip this. So it's 12 over 1 times the reciprocal of 3 halves, or 3 over 2, is 2 over 3, 2/3. Okay, that's not too bad. We multiply straight across. 12 times 2 is 24. Ooh, that's a terrible 4. 1 times 3 is 3. Same thing as what we did over here with the 32 and 5. We need to divide 3 into 24. So 3 goes into 24. 3 doesn't go into 2. 3 goes into 24 how many times? 8 times. Because 8 times 3 is exactly 24, which means your answer here just simplifies to 8. And I kept getting questions with my in-person students is, well, if it's 8 and over here we did 6 2/5, wouldn't it be 8 0/3? Well, yeah, you could write it like that, but 8 0/3, 0 divided by 3, you would just be left with 8 in the end. Okay, so really, this is just a normal division problem. So if I were to have given you a division problem and you were to solve this, you wouldn't tell me that the answer is 0/3. You'd tell me that the answer is 8, right, with no remainder. So our answer is just 8, no remainder. All right, so let's hop into the lesson today. Like I said, I think today is going to be a pretty easy concept for you because you're used to these types of things before. You've seen them before. All right, so let's hop into it and see what you think about it. Okay, so just to talk about a few vocabulary words for you, right? There's 3 weird words I'm going to be throwing out today, and it's integers, a rational number, and opposites, right? Some of them you may have heard before, like opposite, you've definitely heard of that word before. If I were to say, what's the opposite of happy? You'd say sad, right? Well, the same thing. It's the exact same idea. Here are the definitions we're going to be working with, though. An integer is just a whole number. It's a counting number, right? Like your 1, your 2, 3, 4, 5, 6, 7. Those are integers, right? It's not a fraction. A rational number, think of it like, has anyone ever told you like, oh, they're being irrational, right? Well, irrational is the opposite of rational. Rational is meaning that like it's logical, it makes sense. So a rational number, think about it like it's an everyday number. It's a number you're used to. You can see these numbers around. Those are rational numbers, right? And then an opposite, like we were talking about before, it's a number that is an equal distance from 0. And I know that sounds weird, but let's think about it this way. If I were to say 2, right? 2 is 2 hops away from 0, right, on a number line. Well, what's the opposite of a positive 2? Negative 2, because it's 2 spaces to the left on a number line. And we'll look at that today, and hopefully it'll make more sense for you. But these are the 3 things we're going to be working with: integers, rational numbers, and opposites. To dive a little deeper of like the difference between irrational and irrational numbers, these are examples of rational numbers, right? Rational numbers include your integers, your counting numbers, and your whole numbers, right? And you've seen these numbers before. Maybe you've made, like I know for me, I make waffles every now and then. And in my waffle recipe, it asks for 1/3 of a cup of oil. Well, 1/3 is a number that you can see, you can visualize. We work with these numbers often, right? You'll never see on a recipe box it asking for the square root of 8, right? A square root of 8 cups of oil. Aunt Jemima's not asking for that. Aunt Jemima's asking for 7/8, 1/3, 2 cups, 1 cup, right? Logical numbers that we can work with. So whenever I'm asking for a rational number, what I'm asking for is just a normal number that we're used to working with. We're not going to work with irrational numbers, maybe not this year, but one that I know a lot of you have heard of before is this symbol right here, pi, right? The reason it's irrational is because it goes on forever. It's infinite. It's not a number that you can easily see in life, right? I can't say that, the the length of this fireplace right here is pi. Can you see that the length of that is pi? No. But I could say the length of this fireplace right here is 4 feet. Well, you can understand that it's 4 feet, right? So that's a rational number. And then irrational numbers are numbers that are hard to visualize. They're not your everyday numbers. Okay. So let's look a little bit deeper. Here's one thing I want you to think about, especially when it comes to, we're in fall, right? Temperatures are fluctuating from super hot in the afternoon, evening time, and super cold at night. So let me read this to you. It says Sal recorded the outdoor temperature as -4 degrees at 7:30 in the morning. Right, so that's cold. That's cold. That's at winter time. At noon, it was 22 degrees. Sal said that the temperature changed by 18 degrees because 22 minus 4 is 18. So I want you to pause the video and think about what I just said. Think about what Sal is saying in this. He's saying that because it was -4 degrees, right? -4 would be like right about here on this thermostat. He's saying that it's -4 degrees and in the morning, and then by the afternoon, it's 22 degrees. So he's saying that the temperature changed 18 degrees. So he went from here all the way up to here. Is that 18 degrees? Is he right? Why or why not? So think about it, pause the video, and we'll discuss. Okay, so let's talk about it. Hopefully you are thinking about temperatures and how we can be in a temperature that's below 0, right? Like, for example, Sal said that the temperature was -4 degrees. Maybe you've remembered a time when it's been that cold, and maybe you've heard on the news, it's going to be below 10 degrees, right? It's going to be -10 degrees today. Oh, that'd be freezing cold, right? But that's saying that it's colder than 0, which means it's a number less than 0, right? So if Sal says that the temperature is -4 degrees in the morning and then 22 degrees by noon, that means it went from right here, below 0, it went up to 0, and then up 22 degrees. So he says that it changed 18 degrees. But did it? No. Because, and here's why, if it's -4 degrees at 7:30 in the morning, it needs to go 4 degrees up, so 4 degrees hotter to 0. So that right there is 4. And now we're at 0 degrees, which not possible, but 0 degrees. And then it needs to go from 0 degrees all the way up to 22. So it went from 4 degrees plus 22 degrees So in total, the temperature change wasn't 18. The temperature change was 26 degrees because it went from -4 up to 0, which is a 4-degree temperature change, and then it went from 0 to 22, which would be 26 degrees. So Sal would be wrong in this instance. So what we're going to be working with and looking at today are numbers that are less than 0, which would be our negative numbers. And hopefully you've heard of those types of numbers before, because mostly we hear about it when it comes to temperatures. We hear about it when it comes to, hopefully not, but money, right? If you're in debt, dollars, charges, all that kind of stuff. So we're going to look at these types of things. All right, so let's look. So here's our first example. It says the counting numbers, their opposites and 0 are integers. Okay, so there's that vocabulary word again. Numbers that are located on opposite sides of zeros and the same distance from 0 on a number line are called opposites. What integer is the opposite of 6? So let's look at this number line. What it's saying, let me choose a color. Let's do blue. It's saying here's 6 on a number line, right? Okay, we all see that. Here's 0, 1, 2, 3, 4, 5, 6. Positive numbers are going this way. These are our regular numbers. And here's 6. 6 is 1, 2, 3, 4, 5, 6 spaces away from 0. It's valued at 6 because it is 6 away from 0. What it's asking here is what is the opposite of a positive 6? So if we went to the right 6 to get to 6, what happens if we went to the left 6? Let me do red so I match the colors. 1, 2, 3, 4, 5, 6. So 6 is 6 away from 0, and -6 is 6 away from 0, which means that they're opposites. So the opposite of a positive 6 is a -6. And the second question says, what's the opposite of a -6? Well, the opposite of a -6 is a positive 6 because they're both an equal distance away from 0. All right, so if let's forget about 6 for now. Let's try another one. Well, what if I were to say 9? Well, here's 9, and you know 9 is 9 spaces away from 0. That's why it's 9. But what's the opposite of a positive 9? Well, the one that's the equal distance away from 0 this way would be -9, right? Because they're both 9 away from 0. This one's 9 this way, and this one's 9 this way. So 9, positive 9, the opposite is a -9, and the opposite of a -9 is a positive 9. Hopefully that makes sense. We're just looking for what's the opposite. That's it. Okay? So let's try another one. All right, so let's look at this example. It says Riley recorded the temperatures for 5 days in January. Which day was the coldest day of Riley's data? Which day was the warmest day? Write the temperatures from least to greatest. Okay, so let's look at the data first. It says day, Monday, Tuesday, Wednesday, Thursday, Friday. Okay, here's the temperatures. For Monday, it was -5 degrees. For Tuesday, it was -2 degrees. Wednesday, it warmed up. It's 4 degrees, which is still really cold. Thursday is -3 degrees, and Friday is 1 degree, right? So the question is, the first question says, which day is the coldest? So let's think about it. If you've ever watched the news, is it colder when the temperature is really high or when the temperature is really low, right? So which one of these days would be the coldest? Well, -5 would be, because let's say like today it was what? Let me check my phone. It says it is 82 degrees, right? That's pretty warm. Well, what's colder, 82 degrees or 60 degrees? 60 degrees is colder, right? Because the farther down you go in degrees, the colder it gets. So -5 is farther to the left on a number line, which means it's the coldest. So I'm just going to say C. Well, I'll say cold. Cold, right? The second question says, well, which day's the warmest? Well, let's think about the opposite, right? If -5 is the coldest, which number is the highest? Now, these are all pretty cold, but of these 5 days, which one's the warmest? 4 is, because it's the biggest or hottest number. It's the farthest to the right on a number line. So coldest, -5, warmest, 4. Well, now it wants us to write the temperatures from least to greatest. Okay, so we're going to make a number line. Let's do that. My line might not be super neat, but we'll try my best. All right, so let's always, with your number line, start smack dab in the middle. Okay, now we want to put these numbers from least to greatest. So I'm just going to count up 1, 2, 3, 4, 5, 6, 7, 8. So I counted up to 8. None of these numbers are 8, but I'm just going to give myself enough space. Now let's do the same going this way. Now this can be tricky, so pay attention. If this is 1, and this is 2, and this is 3, and so on, when we go this way on a number line, we count the same way in order from 0 to the left. So this first hash mark is -1, which means this second hash mark is -2. So that means this is -3, -4, -5, -6, -7, -8. So think about it as 0 is like the starting point. And if you're going to the positive numbers, it just like normal, like you're used to, 1, 2, 3, 4, 5, 6, 7, 8. For your negative numbers, it's the same thing. You're still counting 1, 2, 3, 4, 5, 6, 7, 8, but just going in the opposite direction. Okay? So now let's figure out which one's from least to greatest. We said Monday was the coldest because it's -5. So 0, -1, -2, -3, -4, -5. -5 would be right here. So that's my least number. Well, what's the next coldest day? If this is the coldest, we're done with Monday. We have -2, 4, -3, 1. Well, we know we still have 2 negatives, which should be somewhere over here, right? Well, what's colder, -2 degrees or -3 degrees? -3 is colder, so that would be here. So it's next in line, which means that -2 would be next. And now we're done with negatives. That leaves us with 1 and 4. Well, what's the next least amount, right? What's the next coldest day? 4 degrees or 1 degree? 1 is colder because here's 1 on the number line. And then 4 is way over here. 3, 4. So that is the warmest day, which means it's the most in value. So our numbers from least to greatest go -5, -3, -2, 1, 4. I know that seems weird when I'm saying least to greatest and you have a bigger number here and a smaller number there. But think about it, right? Negatives means that it's less in value, right? Would you rather be $100 in debt or $1 in debt? You'd rather be $1 in debt because that has more value than being $100 in debt, right? No one wants to be that much in debt, right? Because -100 has less value than at least $1 in debt does, right? Nobody wants to owe Mr. Dotson $100. You'd rather owe me just $1, but nobody wants to owe me anything. All right, so that's example 2. Hopefully this is starting to make a little bit of sense for you. Let's try one more. Okay, I like this example because it really deals with real world, scenarios. It says integers describe many real world situations, including altitude, elevation, depth, temperature, and electrical charges. 0 represents a specific value in all of those situations. What integer represents sea level? The zombie boat? The shark? So let's look at this picture here, right? It's a weird picture, but I want you to think about it. Have you ever passed by, maybe you've been on a road trip and you've seen like a town sign, for example, Frostburg, and it says elevation blank, and it tells you how many feet it is? What that's telling you is how high up that town is compared to sea level, because sea level is 0. That's where everything starts, and then all the land depends on the elevation from sea level. Okay, so that's what this picture is trying to show us. Here's sea level. If you go under sea, right, you're going down in depth, which would be a negative amount. But if you're going above sea level, it would be a positive amount. So again, it says 0 represents a specific value in each situation. What integer represents sea level? And again, that would be 0. 0 represents sea level. Let me choose a color that isn't blue on a blue picture. 0, right? Now, the zombie boat. So here's the zombie, here's the boat. What integer would this zombie boat represent? Well, if I just draw a line straight across, it's at about 20, right? So it's a positive 20 because it's above sea level. Okay. How about the shark? Well, we'll go with, let's go with this shark, this one in the back. If I were to draw a line, it's about in between -10 and -20, right? So if we say it's at this line right here, about halfway in between 10 and 20, -10, -20, what do we think that would be? Again, remember, when you're working with the negatives, it gets smaller numbers and bigger numbers going the opposite way. So if this is -10 and this is -20, in between the two would be -15. Right? So if I were to ask, put these in order from least to greatest, you would say -15 is the least, then 0, and then 20. Because -15 is the least amount, it's less in value, and 20 is the most in value. Okay? So that's what I mean by that. We're not doing anything too crazy. We're just trying to understand where numbers lie in relation to other numbers. All right. So let's try some practice problems. Well, first let me show you a neat trick when we're talking about elevation and stuff. Okay, so I always like to talk about this picture because I don't think a lot of us put 2 and 2 together, because we are up in the mountainous area, right? We're in a mountainous region. For some of you may remember, I've talked about it every now and then. I'm originally from an area right next to Washington, D.C., which is near the Chesapeake Bay. And really, where I'm from, I'm not from a mountainous area. I don't really see mountains. What we saw a lot of are rivers, the bay, and swamps, because we're pretty low to the sea level, right? Because sea level is 0, and then anything above is above sea level, but there's places that are below sea level. You may be a little too young for this, but maybe you've heard about it. There was a bad hurricane that happened where New Orleans was hit, Hurricane Katrina. And the reason it was affected so much is because New Orleans is technically -3 feet below sea level. So when the waves came in and pushed up against the barriers, the levees broke, flooding happened, and technically, since it's a below sea level city, it filled up like a bowl. So look at this picture right here. Sea level is 0, and if New Orleans is -3, if the water got too high, like in a hurricane or a natural disaster, it would be below sea level, which means water would come in, right? Same thing with Miami. Miami is 6 feet above sea level, so they have about the size of, well, if I'm taller than me, they're that much more taller from sea level, so they're plus 6 feet. Chicago is 594 feet above sea level. Denver, Colorado is so it's a positive 5,690 above sea level, right? Let's think about over here. If you look on this list I made, I just Googled, Kaiser is 807 feet above sea level. So it would fall somewhere about here. So if Chicago's 594, it'd be right about here compared to Chicago, right? Frostburg is 2,070 feet. So that if Denver's here, it'd be, this high above sea level. Elk Garden's a little bit more than Frostburg, so it'd be like right here. And I'm from near DC, but in particular Chesapeake Beach. Chesapeake Beach is 49 feet. If Miami is 6 feet and here's sea level, I'd be right about here. 49 feet. So pretty close, which is why whenever we were hit, if a hurricane ever came up the coast or if bad rains, we would flood every now and then. Not as bad as New Orleans or anything like that, but still a possibility. So think about that. All of these places are above sea level, so they'd be a positive elevation. But let's say you were to go in a submarine, like way down here, you'd be at a negative elevation because you are less in value compared to sea level, which is 0. So a submarine might be able to dive hundreds, thousands of feet below sea level. Okay, so if 0 represents sea level, you have elevations above and you can have elevations below. Same thing on a number line. You can have numbers in the positive range, but you can also have negative numbers. There's such thing, and we work with negative numbers. Okay? So hopefully that makes sense that there is such thing as negatives, and we have them in everyday life. Let's try these practice problems out. So for the first one, I just want us to tell what are the opposite of each integer, each number, each counting number that's here. So what's the opposite of each one of these numbers? If you want to pause the video and try these on your own first, go for it. Okay, so pause the video. I'll give you a chance. You can pause the video before I spoil it for all these answers. See if you can do it on your own first, and then we can check. So pause. Did you give yourself enough time, hopefully? Let's find out if you did. Number 1. 1. And it's a positive 1. There is no negative sign next to it. What is the opposite of a positive 1? 1, positive 1, is one space away from 0. Well, what's one space away from 0 this way? Negative 1. So the opposite of a positive 1 is a negative 1. What's the opposite of a negative 11? Positive 11, because they both are 11 spaces from 0. This one's tricky. If 0 is our baseline, if that's where we begin, it's the origin, right? Is there an opposite of 0? No, because 0 is 0 away from 0. So the opposite of 0 is still 0. Now, these are a little bit more tricky. Let me read this to you. And before I do, think about what I'm asking here. I'm asking for the opposite of a number. If we think of this negative here, we're saying a negative 8. So the opposite of a negative 8. So the negative, a double negative. Have you ever heard of, maybe this is, I'm dating myself here, but back when I was in school, there used to be like, I didn't not do that, right? Or I didn't not steal your candy, right? If somebody says that, they stole your candy, because they're saying that if I were to say I didn't steal your candy, okay, then I didn't steal your candy. But if I said I didn't not steal your candy, that's a double negative, which means I definitely stole your candy. That's the same thing as what this is saying. A negative is really just a positive 8, right? So negative 8 is a positive 8. Now let's find what's the opposite of a positive 8. Well, the opposite is a negative 8. Okay? I know that seems weird, and I'm not going to give these to you often, but when we do get to algebra, it'll make sense why I'm going over this, because we are going to work with double negatives. But let's look at this one. Same thing. A negative 65. So a not 65. So negative 65, but a not a negative 65 would be a positive 65. So what's the opposite? What's the opposite of a positive 65? Negative 65. Again, weird, but it'll make sense later on why we're going over that. So hopefully this makes sense. Whatever number you see, if it's a positive, give me the negative. If it's a negative, give me the positive. If it's a 0, it's just 0. If you see a double negative means positive, give me the opposite, it's a negative. Okay. All right, so let's try this last one. It says write the integers from least to greatest. So let's use our number line to just plot all of these numbers first, and then we'll be able to see which one's less in value, which one's more in value. So first one's 2. So we'll just put a big old dot on 2. So there's 2. That's a little hard to see. Let's choose a green. So here's 2. -3, so we want to go to -3 and put a dot. 0, we know where that is. We put a 0, right, a dot right above 0. And then -4, put a dot. Okay, so there's all of the numbers we're working with, all of the integers put on our number line. Positive numbers are on the right, negative numbers are on the left. Start at 0, -1, -2, -3, -4. So if my numbers are less in value to the left on a number line, right, to the left on a number line, and the more in value numbers go to the right on a number line, if I'm trying to figure out which one's from least to greatest, well, which one's farthest on the left? -4. So that's the least in value. Next would be -3. Moving along the line from left to right, 0 would be more in value. And then the number that's the greatest is 2. So if you're ever looking for which one's less in value, look to the less left. Greater than right. Greater right. Less left. Right? So hopefully that helps out. Really 2-1, the practice problems are exactly this right here. So if you get stumped, just come back to this part in the video, watch it over again, and hopefully it'll make sense and you can get 100% on your assignment. Just remember opposites. If it's a positive, give me the negative. If it's a negative, give me the positive. Use a number line to plot your points to figure out from least to greatest, okay? All right, so as I said, what I want you to really be focusing on, this lesson wasn't that difficult, hopefully not that difficult for you. I want you to use the time that you will have for my in-person kids. You'll have some time in class. For my virtual kids, I only gave you really one assignment for this week and it wasn't that difficult. Take this time to catch up. You're on week 8. You only have this week and next week. Grades are going to end up closing. Teachers are going to have to put all the grades into Schoology and then send that over because the first 9 weeks is ending. Make sure everything is turned in. If you have any zeros, see if it's because you didn't do the assignment. Get the assignment done. Talk to your teachers. See what you can do to get your grades up. Because this is a good time to make sure that you have everything under control, that your grades are looking good, and that you're good to go for the first 9 weeks, and we can have smooth sailing into the second 9 weeks. So take this time to catch up. That's why I'm not giving you many assignments for this week. Okay? So the only other assignment that you can work on, as I said in the beginning of the video, is the red tide analysis, and that's in a separate folder for my virtual students. My in-person students will be doing this in class on either Tuesday or Friday. It's just a current event activity that I think is pretty neat because it talks about hurricanes and how math is involved and how it affects the environment and all that kind of good stuff. So it's not a grade. If you get caught up and you want something extra to do, give it a look. I'm making a separate video that's going to go inside that folder that explains it more and to show you how math is related to hurricanes and the environment and how it affects us. Okay, so that's all I have for you for this week. Thank you for watching the video. Please come back next week to see what your last week assignment is. And if you have any questions, contact me on Schoology, send me an email, and I'll be happy to reply. So until next time, stay safe, stay healthy, and I'll see you in the next video.